It's September 1977. You're playing one of the first video game consoles released in North America. You step outside and see the whole neighborhood waiting for Voyager 1 to launch. It's a super sunny day, so you squint a little, trying to see what's happening. You live in the neighborhood right outside the launching station. You get yourself some food and watch the Voyager take off into space. You're so impressed, you decide to dedicate your career to working with NASA. 35 years later, you're now a senior official in NASA, specializing in Voyager 1. It's 2012, and you're sitting in the control room with your colleagues. Everyone is staring at their computer screens as they work on the Voyager. You're sitting on the top, overlooking everything and making sure all systems are in check. This day is special, as Voyager 1 is about to exit the heliosphere, which is a science word for the outer shell of our solar system. It's a bubble of space affected by the solar wind, which comes from the sun. By 2021, it got 14 billion miles away from Earth, which is equivalent to 153 astronomical units from the sun. 1 astronomical unit is the distance between the sun and the Earth. The craft was originally meant to fly by Uranus, Saturn, and Jupiter, and toss itself from one planet to another with the use of their gravitational pull. Everyone is impatiently waiting for it to exit the heliosphere. 3, 2, 1, and it's officially out. All systems are normal and functioning. You praise your team for doing an excellent job. With Voyager 1 reaching this far, there's still tons to explore in outer space. You were once a young adult watching the craft launch outside your neighborhood, and now you're the main person in charge of the operation. 9 years later. Since Voyager 1 left the heliosphere, you've been checking up on it every now and then, making sure all systems and functions are in order. It's been sending back measurements of the interstellar medium. It's the area between the stars of our galaxy, consisting of ionized materials. Ionized is basically a simple version of a molecule or substance. The interstellar medium is an electrically charged state of plasma, or ionized plasma, and is very unstable. It's like going from lightning in a thunderstorm back to calm rain in a matter of seconds. The plasma up there is different than the plasma on Earth, in that it's difficult to filter out. There are around 0.06 atoms for every cubic inch in the interstellar medium. The air we breathe on Earth has billions of atoms. By measuring the plasma in the interstellar medium, we can further understand the behavior and structure of chemicals and gases. It's possible that the oxygen we know and love on Earth is different than the ones out there. One of your main tasks is to learn more about how the solar wind from the sun and interstellar medium interact with each other to create the heliosphere. So, after doing some routine checkups and other maintenance work on Voyager 1 from the control room, you notice something strange coming from the screen. You sit in front of the computer, crunching the numbers of the plasma vibrations and convert them into an audio file of about 3 kilohertz. You click on it and listen to an eerie, subtle hum. You and your team are surprised that these vibrations occurred in such a small frequency. Given that space is massive, something like this might mean life on other planets. Everyone else at the station rushes to the control room to listen to that sound from outer space. It's monotonous and faint, but it's definitely coming from outside the heliosphere. You run the numbers over and over to make sure it's not a fluke, but it's on point. You make sure your team doesn't spill the beans to anyone outside until everything is known and clear. You get into beast mode with work and try to catch the sound again, and it remains. You can't sleep trying to think of something that could be producing this hum. A few days pass by, and the sound is pretty consistent. If there was some life out there trying to communicate with you, then surely it would have said something that can be deciphered. You analyze the audio files once again, trying to see if it's some phonetic language you don't know. You call in a linguist to see if she can make something out of it. You and the squad gather around, waiting impatiently for some answers. After a while, she believes that it might be someone out there communicating with us, but the only way to find out is by sending something back to them. You arrange a meeting with your team and try to figure out what message you can send. After much thinking and lots of coffee, you decide to send them one phrase in English. Who are you? You send out the signal through Voyager 1 and wait for any changes in the hum, but you don't get anything straight away. It may take some time for a response. You wait all night and still, there's nothing. It's starting to look like there isn't anything out there. For the next couple of days, you keep sending out phrases for anything to pick up. Since space is a vacuum, sound waves can't travel, so sending out voice messages on a large speaker won't work. You locate the source of the humming and aim for it when sending the audio file. Every day, you send something different, but still, you don't hear anything from them for a week. It seems that intelligent life in the distant world isn't real. The areas between the star systems in a galaxy aren't necessarily a complete vacuum. That's where the interstellar medium is. It contains gases, dust, and cosmic rays, which are energy particles. After many months of this constant humming being produced, you still try to figure out what's going on. You sit there, remembering the time when the Voyager was first launched. You remember running outside after playing some video games. You couldn't see properly because of the sun, and you freeze in your spot and have a eureka moment. You go through some notes taken in the past. The answer was in front of you all this time. Every now and then, the sun sends a burst of energy that causes the plasma of interstellar space to vibrate. Scientists can measure the frequency of waves when the plasma vibrates to show how close they are to each other. And on the day when the hum was delivered, there were some irregular frequencies coming from the sun. So that hum might have been the plasma vibrating in a weird way because of the sun flares. But these low-level vibrations last longer than quick jumps and spikes. They're fainter. You run the tests again and find out that it's not some intelligent life forms out there trying to talk to you. It's the little vibrations caused by sun flares. You notify your team about this breakthrough, and everyone's celebrating. But after all these tests and research, you still don't know why plasma in the interstellar medium vibrates in such a way. Those answers will have to wait. 2027. It's been 50 years since the launch of Voyager 1. You're way into your senior years and just retired from NASA. You have many scholarships in your name and programs for young people who want to learn about space and science. You go back to the control room once more, where you thought you had discovered intelligent life on a distant world. Then you remember all the good times you had. You say goodbye to everything, knowing that this is Voyager's final moments. It was built to last up to 50 years. After that, it'll just be a floating object in the vastness of space. It's already surprising to know that this is Earth's most distant object from us, but it's time to let others take your place. You shut off the lights and close the door. The Voyager makes one last beep before eternal silence.
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, hey, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, you know, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, a giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops! That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.